Everyone to DevSecOps, stop shifting left and start left instead. Please welcome our presenter, Jacob Wyllie, the Director of Cybersecurity for Ethical Intruder.
Hi, Ryan. Thank you, everybody, thank you for joining. As Ryan said, today we're going to be talking about DevSecOps and sort of what that means to the modern software development company, and just sort of the differences between some of those the terms that we've heard thrown around, especially that buzzword, that shift left buzzword. So today I want to discuss a few topics, what DevOps and DevSecOps really mean and the differences between them. And I know the previous session sort of dove into that a little early on. So with that, I'm going to go ahead and get started. So here we have a few diagrams showing what DevOps and DevSecOps mean. And in order to understand where that shift left term sort of comes from, we're going to talk about how sort of DevOps originated, what it means in modern terms, and how we can modernize that term even further to match the current software development landscape. So DevOps is a term that was coined back in 2008. And as you can see in the diagram here, it's the idea behind DevOps was the cross-functional collaboration between each of those functional areas. So the software development team, the ops and IT team, which would typically be a system administrator role, and the quality assurance team, which would be a QA engineer or a test automation engineer. And it's much more than just that cross-functional collaboration. DevOps is also a cultural change. So it's a shift in processes, and to mention a common paradigm that a lot of people are familiar with, the people, process, and technology paradigm. So it's a shift in from older, more waterfall type processes of software development to a more agile focused and more lean and efficient method. And so the intention behind DevOps was really to remove the business silos that came about as a result of waterfall. So we had a system administrator and network engineering team. We had a software development team. We had a quality engineering team. And those teams really just focused solely on the areas that they were domain level experts in. And what that did was, when it came time to release, the next iteration of a software project, we had a ton of hoops and approvals to jump through right prior to release that ended up delaying and causing bugs and vulnerabilities in the software development process, because the process was so rushed to get everything out the door and on time and on budget. So DevOps was intended to sort of remove those barriers to software development, and it did a great job. So great, in fact, that the efficiency and improvements in release time and product development outpaced older, outdated security models. So the DevSecOps and shift left terms were sort of coined as a result of that improvement in the pace and efficiency of software development. So that's sort of why DevSecOps was necessary. But the focus of DevOps really was improving SDLC, improving that process, and along the way, as I mentioned earlier, security became more of a checkbox. So not only did that pace and efficiency improve, but the fact that security became more of a checkbox prior to release became an issue for, actually, oops, I just realized that I was not in presentation mode. So let me start that again. Okay. There we go. Whoops, sorry about that. Okay, sorry. For some reason, it's coming up in that weird mode. So, sorry, jumping back in. So nothing is really fundamentally different about DevSecOps. It's really just adding security to the pre-existing notion of DevOps and that security model, right? But what adding security to the equation has done really has pushed for earlier engagements with cybersecurity teams within organizations and coined that shift left buzzword term. And shifting left sort of became the call to arms of the DevSecOps movement. So now we're gonna get into what that looks like and why that model has sort of become outdated in modern software development. So typical depictions of modern software development and the shift left concept are depicted linearly, as shown in the depiction on the left here. So more as a sentence, and this sort of is a holdover from the previous waterfall methods. So where software was developed, built, tested, and then deployed sort of linearly, and at each stage there was a quality gate sort of that went into that. And security, really, the idea behind shift left was, well, if we start to test for security and engage with cybersecurity teams earlier on in that linear process, then there will be a lot of improvements. And so those improvements, how this concept was sold to management and pushed in organizations is displayed on the right here, and this cost of remediation. So within that, the cost of remediation, we're going to talk a little bit about, and I know it's been mentioned several times, an example. And one of those examples would be the Colonial Pipeline hack, which has been discussed several times over the last few days. So if a bug related to a ransomware attack is caught in the design phase, an architect could easily change that design and remove that vulnerability before it even makes its way into a code base. If it's caught during development or during that build phase, then it would be easy to refactor that code prior to even undergoing testing or even after testing. If it's caught during the testing phase, then it would be, a QA engineer could take a look at what that bug looks like, document what that bug looks like, and then pass that back to the development team, and the development team can go ahead and take care of that. During deployment, that's really where we start to see a great increase in the cost of remediation there. And the reason for that is the fact that infrastructure has now been deployed and code has been deployed on infrastructure. So there's a resulting change that needs to occur within that infrastructure, and we need to get operations teams involved, and that's where you have sort of on-call issues and issues that need to be addressed out in the wild. And then obviously post-breach, going back to the Colonial Pipeline hack, some issues can come up that result in millions of dollars of financial harm and reputational loss. So the reasoning behind shifting left and the intention from a security perspective was to lower that cost of remediation and remove security bugs earlier on in the process, so that the harmful effects of some of those security bugs and vulnerabilities weren't felt as heavily by the organization. And so that's how that was marketed to organizations and management teams sort of across the board. And you can see why that's a really compelling story, especially given some of the crises that we've seen recently. And so over the course of the last few days, we've talked a lot about the Colonial Pipeline attack and SolarWinds. And it's really easy to see how organizations can get behind that shift left concept. But unfortunately, modern software development really doesn't follow that linear model anymore. It's a little more complex, a little more, a little less linear, and a little more cyclical than that. So this next slide is going to go into sort of a better model, but not quite a perfect model of what what it means to shift left. So shifting left in this model has this cyclical diagram. This is more so what modern DevOps and modern DevSecOps looks like, where you have a design and planning phase, you have a coding phase, you build the code that you've written, you test that code, you release it, you deploy it, and then you have a web application firewall or a SIEM that monitors all that stuff when it goes into production. And at each of those stages, there's some security tooling that is part of the measures that protect an organization and protect those, protect that software product. So modern DevOps and modern SDLC process follows this more iterative and complex nonlinear process. Security improvements, can't be achieved just by this shift left concept of testing and when security engagements happen. So modern software projects, as I mentioned earlier, are a complex ecosystem of microservices and micro apps. And they no longer have to adhere to using the same technology stack. So previously, in more monolithic architecture, everybody was using the same frameworks, the same technologies, and everything was sort of self-contained in one code base. Now we have totally disparate teams working on separate microservices and micro applications that don't necessarily have to use that same technology stack. They can be technology stack agnostic and can be at all different phases of the software development lifecycle. So security teams can get engaged with totally separate teams at totally different stages of the software development lifecycle, and that happens very frequently in organizations nowadays. Another point I want to bring up here and sort of shift left evokes that sense that we're shifting the responsibility of security to development teams. So development teams are typically already really strained to adhere to that mantra that is very familiar to a lot of us of on time, on budget, and exceed expectations of the project, right? So one of the ways that the software industry has matured to address that business need is through feature-based development and through the usage of open source dependencies. So unfortunately, when you integrate those solutions into a software development lifecycle, you come up with some additional security challenges, chiefly ensuring that those open source dependencies are secure and you're not susceptible to a supply chain attack. So oftentimes that dependency tree for some of those open source projects is 3 or 4 levels deep, if not more, and organizations aren't even aware of how many open source dependencies they're really relying on for enterprise software that's out in production. They haven't audited those open source dependencies, and that presents a real problem, as seen with the SolarWinds attack and some of the recent supply chain issues that have come up. So to go back to sort of the shift left concept, the shifting left concept does evoke that sense that the focus of security teams is really now primarily focused on development rather than and nipping these vulnerabilities in the bud, so to speak, rather than remediating or investigating incidents after the fact or forensics. And it feels like that responsibility is sort of being shifted more on the development team, which is why that shift left concept has become a little dated in modern software development. And so I'm sure that many folks here can sort of attest to the fact that due to that, security sort of has a reputation among some of our colleagues that security slows development down. It hampers efficiency. And generally, security are the folks who tend to say no to a lot of the requests that come from software development teams. But that really doesn't have to be the case if DevSecOps is presented outside of this shift left concept. And that's sort of where this term that Ethical Intruder likes to use internally, this start left mentality, has come about, and that's what I'm going to get into next. So the start left mentality really can be best explained through the 6 pillars of DevSecOps. And the 6 pillars of DevSecOps have been defined by the Cloud Security Alliance, and they're really integral components to successfully implementing and adhering to the DevSecOps model. All of which can be tied into that term that we've coined and that mindset of starting left. So starting left, much like DevOps, is more so a a cultural change and a shift in process as compared to shifting left, which really just consisted of a process change, right? That process change was doing security testing earlier on in the development lifecycle and engaging with cybersecurity teams internally earlier on in that software development lifecycle. So that the cultural change of the start left mentality really consists of raising the security awareness within each of those functional areas mentioned above, to the point that security is sort of baked into the process, the SDLC process, from its inception. So during the design and architecting phase. Starting left can also mean, rather than viewing security as another checkbox that needs to be satisfied prior to release, viewing cybersecurity teams as a partner and integrating them within already existing processes used by software development teams during the software development lifecycle. So with that, we're sort of going to adapt that start left mindset and go into how each of these pillars sort of embodies that mindset. And the first pillar is that collective responsibility. So sort of to piggyback off of that partnership concept, security can't just be the responsibility of a cybersecurity department or a cybersecurity team. It has to be prioritized by an organization's leadership and has to be pushed from the top down. So security should be considered holistically and viewed as a critical feature of any software project rather than a requirement to be implemented once development on business features and the actual project itself has been completed. So going back to that idea that security isn't just a checkbox that a team has to satisfy in order to get their code into production, it's really should be viewed as a feature of the software project that they're developing. So this idea embodies that cultural change associated with the start left mentality. The second pillar is collaboration and integration, right? So employees and organizations, especially over the course of the pandemic, which has accelerated that shift to the cloud, have completely varying degrees of knowledge about cybersecurity and new technologies, especially as some of these newer cloud technologies and new frameworks have made their way into organizations' tech stacks, and more secure design patterns have emerged. So some of those secure design patterns have been, for example, immutable state architecture and React, and the Redux design pattern and UI. So one of those considerations that security partners and software development teams should focus on is when we're selecting tools and frameworks within a tech stack, security should be one of the primary things discussed at the early onset design and architecting phase of the project, just because they remove a lot of the security issues that can come about as a result later on down the road if security isn't baked in from the initial process. Some of the other things to consider in that regard are modern frameworks very oftentimes have security best practices baked in. So user sanitization, preventing of attacks such as cross-site scripting, adding in content security policies by default, preventing SQL injection. Those are all features of modern front-end frameworks that you want to take a look at and read the security documentation of whatever frameworks are being considered prior to just jumping in and focusing on how can I get to market as fast as possible with this software project. That third pillar, pragmatic implementation, is probably, my favorite and one of the more important ones on this list. And this pillar sort of starts the more technology focused pillars within DevSecOps, whereas the first two were sort of more culture and process based. So the mantra for pragmatic implementation definitely has to be, vet your tools, vet your tech stack, debate all of those architecture decisions that I was just talking about. Debate, why do you want to use a specific framework? What's the reasoning behind, adding this specific testing framework, or following a specific design pattern like Redux. Make sure you're auditing your supply chain as part of pragmatic implementation, especially any open source dependencies. So if doing these things earlier on and at the onset of the software development project will help not only in terms of security, but you can actually really increase the application's performance. In addition, especially through the immutable state design pattern, and potentially provide cost savings to the business as a result. So again, not only does not having an incident save your company money in terms of return on investment for remediation, but improving application performance also makes customers really happy. One other thing that's really important to consider here, and it's actually another one of the OWASP top 10, is ease of use for developers, operations, QA staff, and the operational value that tools and frameworks provide, right? So the reason that that's really important is depending on how complex and how difficult it is to deploy some of these tools selected as part of this pragmatic implementation pillar, you could really run into the risk of misconfiguring those tools. And that's a very common issue seen and documented in the OWASP top 10. So the next pillar would be bridging compliance and development. And this is probably one of the more difficult pillars to do effectively and consistently, and one of the more complex concepts. So what that really consists of should be identifying the gaps between compliance and your organization's actual security posture. And so a panel yesterday gave a really interesting example in terms of some compliances have a requirement that you have a firewall. So if you have a firewall, you're technically compliant, but that doesn't mean that you're actually secure, because your firewall rules are really what make you secure. The configuration of that firewall is really what makes you secure. So identifying the gaps between being compliant and actually having a true security mindset and a security valid security posture are some of the issues that we're working to resolve as part of this pillar. So one way to achieve this is, and in the DevSecOps model, is to use infrastructure as code and policy as code, and we'll get into that a little later when we get to the automation pillar. So the tooling selected and implemented during that pragmatic implementation phase should really provide quantitative data that you can audit and map back to a control or policy that satisfies one of these compliance requirements, right? So it's that mindset, to go back to the sort of the Venn diagram of each of those cross-functional areas of how can we tie compliance and technology together to really satisfy the needs of the business, and not only ensure that, yes, we would pass an audit for a specific compliance, but also that our organization actually is protected from a breach and from reputational harm. So the next pillar is automation. And obviously automation vastly improves the efficiency and thoroughness of software development lifecycle processes. Another feature of automation is that it creates a really easily audited trail of actions within those processes. So it's great to have documents and procedures that people follow, but the actions that people take in terms of user actions within some of these tools leaves something to be desired in terms of an audit trail. So automation tools really resolve that by having a very clear audit log, knowing where that's stored, being able to aggregate that into other tools, and really provide a an overall view that is actionable from an organizational standpoint. To revisit the infrastructure as code and policy as code concept. So infrastructure as code is a concept where software developers sort of realize that the cloud native approach, provisioning cloud infrastructure, could be as simple as writing a script to provision that infrastructure during the build and deployment phases of the software development lifecycle. So infrastructure as code, the idea behind it is automating the process of provisioning cloud infrastructure, VMs, wherever the software project itself is hosted. And again, the benefits to doing that are that it's auditable and version controlled, just like any other code base. So you can see who made what changes to your infrastructure provisioning scripts, what changes were made. You can roll back. It's easy to provision multiple instances for staging and production environments. So the benefits there are sort of numerous. Policy as code is sort of an addition to that infrastructure as code concept, and that policy as code can ensure that the provisioned infrastructure adheres to specific guidelines that the organization wants to follow. So for example, an EC2 instance provisioned in AWS, you could ensure that that server where that software project is hosted will only communicate via TLS 1.2 or has specific rule-based access controls in place. So policy as code, again, sort of works the same way in that it's auditable, it's version controlled, it's uniform across the board. So no matter who is doing the infrastructure provisioning, you can be certain that when that infrastructure is provisioned, it adheres to the policies there. And then that final pillar, really the measure, monitor, report, and action, is sort of how you tie everything together. So you want to create a feedback loop that allows your organization to gather actionable intelligence at various stages in the SDLC process. And some of the information that you'd really want to focus on gathering and give feedback early on in the SDLC process and in the DevSecOps process is through code coverage, compliance with security and code quality rules, logging information. And those are just some of the examples of the variety of information that can be collected, analyzed, and acted on by an organization to improve their security posture. So that's sort of how the shift left concept has become dated, and how the modern DevSecOps model embodies that start left concept. So I'm sure a lot of organizations might be interested in implementing this DevSecOps model and embarking on their own journey with that start left mindset, but they're unsure of where or how to begin, or they've already begun, but they're sort of overwhelmed and don't know how to get the ball rolling, especially after looking at resources like this. So this is the cloud native computing landscape. And so basically it's broken out into each of a certain business function that each of these tools would satisfy. And so it looks at first glance really busy and chaotic, and it would be really difficult to continue to vet each of these tools, decide which one is right for the organization. And it can be a little overwhelming in terms of what you're looking at. So what the Cloud Native Computing Foundation did is they created this trail map to sort of help organizations walk through evaluating some of those tools, looking at best practices and how they could move towards a DevSecOps model and integrate security into the software development lifecycle and satisfy some of the requirements that the DevOps just didn't satisfy. So organizations at any cybersecurity maturity level can begin moving down this trail, investigating some of these tools, evaluating where they're at, and even if they've already started sort of moving down this path and evaluating some of these tools, there's some security considerations that are brought up, and we've seen as a security practitioner in the area, and that's what we're going to get into next. are some of the common issues that we've seen and sort of how organizations can get started. So some of the common issues that we've seen, especially with organizations who have attempted to begin moving towards a DevSecOps model or integrating security into their software development lifecycle, that some of the issues that they run into are tools and configurations are partially implemented, and the reasons for that are various, right? So sometimes it's a resource and time issue. Sometimes it's a lack of expertise issue, to go back to the previous discussion about finding the correct talent that has the skill sets necessary. And so as a result, some of the common issues that we see are API keys and secrets hard-coded into code bases, just a general lack of automation. So to use Azure as an example, you could be using Azure CI DevOps pipelines to build your code base, but then if you have if you're hosting that code base in an on-prem server, there's no infrastructure as code provisioning for that on-prem server. And so there's a lack of automation and provisioning that and deploying that software to that infrastructure. So it then becomes necessary for a person to manually go in and pull those keys and secrets into a code base, or to pull them from where they're stored and add them to that on-prem server. Another thing that we've seen quite a bit is a lack of automation surrounding security testing. So static code analysis and dynamic application security testing within internal code, and the fact that there's no auditing solution for open source dependencies. So within a software development pipeline in DevOps, a CI/CD pipeline, static code analysis tools and dynamic application security testing tools can be integrated into that pipeline and analyze the security posture of that code, per build or per release, however an organization would want to configure it, in addition to auditing some of the open source dependencies of that software development project. This is a really big one, and an IBM report actually really goes into the fact that this is a huge area of concern for a lot of organizations, in that they really don't understand container security. There's no golden image solution. There's no container management. So that looks like it's a primary area of concern for this shift to cloud native. And then sort of the last one there is improperly configured role-based access policies put in place, and just a lack of the appropriate configuration of infrastructure. So on an analysis of Kubernetes and some of the cloud environments, the last discussion, the last panel directly before this talked a lot about GCP and Azure and AWS, and how there's been a lot of changes to implement security by default, and the community itself has become a lot more security conscious as a result of some of those things. But organizations really have to ensure that they're taking ownership of the infrastructure that they're provisioning and that's being used to host their software projects, and make sure that those policies are implemented, and they're not relying on the big technology companies to enforce security prior to it being deployed. So again, how could an organization get started if they were interested in doing this, and how could they sort of tailor that roadmap that the Cloud Native Computing Foundation has created to their sort of use case, and make it fit the organizational requirements that they have? So the first sort of step in doing that would be to inventory what the current software development lifecycle process looks like, and the tech stack in use, and then establish what that formal baseline sort of looks like. So inventory the tools, inventory who has access to those tools from an entitlement perspective, the process, the team norms of development teams, how they interact with QA teams, how they interact with cybersecurity teams, and really get a 10,000 foot view organizationally of, from end to end, how do we develop software, and how is security currently implemented in that software development lifecycle. And then as an organization, again, there should be some discussion and agreement on the goals of the organization, and an organization should build a realistic timeline and roadmap tailored to the requirements for that organization. So many organizations looking at this would say, this is really complex, or, after a breach like the Colonial pipeline, you could be at either end of the spectrum there of, we really need to implement all these solutions right now in order to protect our company, or, yeah, we're not necessarily super worried about this. So having the appropriate level of concern from a security perspective of what the benefits are at building a roadmap like this and how it can be done securely is really important, and making sure that everybody is on board with that roadmap and on the same page. And then obviously, there will be challenges along the way. So the next step would just, begin executing that roadmap and plan for those challenges along the way. And one of the really important things about running into those challenges is don't be afraid to engage security partners, view cybersecurity teams internally as a partner in the software development lifecycle, view security as a feature, not as a checkbox, and make sure that those challenges are documented and those lessons learned along the way don't become tribal knowledge. And so with that, I know we started a few minutes late. I'm going to open it up to any questions. Which I think might just actually be networking. I think we're actually 10 minutes over.
Yeah, thank you, Jacob. That was great, very informative. We are now going to head into the attendee networking. You can find the link on your sched or in the chat box. And then we will reconvene at 11 a.m. for the closing keynote. So thank you again, Jacob and Ethical Intruder.
Thank you.